Today we're going to be talking about exponential regression. We will be able to use data and technology to find the equation of exponential regression, and we will be able to use that equation to predict other values. So zombie outbreak. Zombies are attacking. The world is in danger of being overtaken by zombies. Each zombie only has enough venom to attack 2 other people, causing them to become zombies. However, after 1 month, the zombie venom will be cleared from their system and they go back to living a normal life. The attack rate and the zombie period, the time between attack and being a zombie, of the venom has been approximated by studying existing zombies. The attack rate is 2 and the zombie period would be about 30 days or roughly a month. That means that the first zombie would be expected to attack 2 people in 30 days. After 30 days, that person cannot zombify anyone else. This assumes that the spread of the venom is not checked by a cure. So, here's our table of how many zombies we have. So the first month, 1 person's attacked. They're going to attack 2 new people. Those 2 are going to attack 4 new people. Those 4 attack 8, and those 8, 16, those 16, 32, and so on. So at the end of 2 months, we end up having 2,047 zombies. So we're going to let X represent the number of months. So our top row here, those are our X's. And then our Y's are going to be the total number of zombies, so the bottom row. The middle row is just sort of there to help you see where our total number of zombies is coming from. So let's create a scatter plot on Desmos. So we're going to click the plus and then table. And so our X values are 0, 1, 2, 3, all the way up to 10. So we start with 1 zombie, then 3, 7, 15, 31, 63, 27, 255, 11, 23, and 2047. All right, so we're going to click our wrench, and what was our recommended? We're going to do X from -2 to 15 and Y to -2 to 3,000. Okay, so now I'm going to move it a little bit to make it a little easier to see. We can see that it's slowly increasing and then it gets more and more rapid. And if you recall, this is the same shape as our exponential functions. So our graph kind of looks really hard to see. But it starts off slow and then curves up. Okay. So steps to create an equation of best fit for exponentials. First, we're going to input the data. Click the plus, then table like we just did. Our formula for exponential regression is y1 and the squiggle a times b to the x1 power. I'm going to go ahead and put that in. Y1 the x1 power. Now, something special that we have to click, we need to check this box that says log mode, okay? So then we can use that to write our equation with the a and b values that are here. So y equals 1.414, I'm going to round to 3 decimal places, times 2.096 to the x power. That would be my exponential function. So use the exponential model to determine the total number of zombies 15 months after the initial attack. So y equals 1.414 times 2.096 to the 15th power, because x was our number of months. So I'm going to go ahead and plug that in here. And we find out that we would have 93,609 zombies. We're not going to include the 0.2. We're going to round to the nearest zombie because it makes more sense to have a whole number of zombies. So we have 93,609 zombies. Then we're going to use the exponential function to write an equation that can be used to determine when there will be 2 million zombies. So that's our y. Our y is the number of zombies. So we're going to have 2 million zombies. And then we'll still have x as our exponent because we don't know how many months it's going to take. There is a way to solve this algebraically using logarithms. However, we are going to use our graph to solve this. So I'm going to clear out what's in here already. So I'm going to put y equals 2 million. Yeah. And then I'm going to put our equation in the other one. Okay, obviously, we're not going to see 2 million on this graph right now. You can scroll like this forever, or you can adjust the y-axis. I'm going to do about 1,500,000. On the other side, 2,500,000. There's that. Now we're just there. Just zoom out till we find our curve. And they intersect at 19.137. And that was how much time. So there's about 19 months before there's 2 million zombies in the world. If the zombies are not stopped before half the world's population is attacked, there will be no way for humanity to recover. How long do scientists have to find a cure for the venom? So we know We're going to assume the population is about 7 billion, so we want 3.5 billion. And still equal to our same equation. So same thing that we did last time. Again, you can solve algebraically with logarithms. We're not doing that. We're going to solve by graphing. So instead of 2 million, we're going to have 3.5 billion. All right, so I'm going to go to my wrench again and obviously increase this y-axis to about 3 billion. And then we'll do 4 billion for the other one. There we go. There's my line. There's my black line. So it intersects at 29.228. So in about 29 months. So that's approximately 2 years and 5 months that the scientists have to find the antidote for the zombie venom and save the world. That's all for today. I'll see you in class.